Hi guys, how's it going today? Um, we are going to be taking some notes today. Your objective, make sure you write this down. Here's our topic. We're writing equations of line. So get that copied down into your notes, and we're going to jump right into how we do that. And it's probably mostly going to be a reminder, so it's going to be quick. Stop me if you need to write some things down, do some math. If you have a question you don't understand, make sure you write that question down. Be ready to ask for it tomorrow. All right, so um, what I'm asking right now is you see I've got a little mountain here. This guy's I don't know why he's not riding his bike up the mountain, but whatever. He's walking up the mountain and he's going up this slope. And what I want you to do is write the equation of this line in slope intercept form. Now the words slope intercept tell you a lot of things. The slope indicates that you get to write down the slope, which is this part of your equation. And the intercept is talking about where that line crosses your y-axis. That's your y-intercept. So slope is your m and intercept is your b. It's your constant. Okay, and it's pretty easy to do. Things that you pay attention to. The y-intercept. Now we know that it's right here on the y-axis. And so the slope, the y-intercept is 0, 2, with this being the number that we're going to plug in. And the slope. Now, things to pay attention to. Is this slope positive or negative? Now, a shortcut to knowing the answer to that is since it's rising up from the left, it's going to be a positive slope in this situation. Now, how do you determine that? What you do is you just connect two points vertically and horizontally, and you can connect them going this direction. This is a rise of 1 and a run of 3. It's up 1 and right 3, so those are positive, so the slope is 1/3. Now, some people say, but Mrs. Frame, what if we decide to go from this point to this point? It's always your rise, your change in y. This is your vertical movement here. This is down 2 because we're connecting from this point. It's the up and down movement first, and then we're going to go left 6. And that's a slope of negative 2, negative 2 over negative 6. Both of those, 1/3 and negative 2/6, are equal to each other. Negative divided by negative is positive. And you know what? 2/6 reduces down to 1/3. So it doesn't matter if you make an error or you get 2 points that are far apart and you count their rise and their run, or if you get 2 in a row. It doesn't matter if you go from left to right as you find your rise over your run, or you go from right to left and do that down 3, -1 motion. Doesn't matter as long as you remember that the rise is your up and down movement over your run, which is your left to right movement. Okay, so we can see that our equation is our slope is 1/3 and our y-intercept is 2. And that's the equation of the line. Linear equations always have an x and a y in them if the line is diagonal like this one here. You'll notice that this isn't a very steep slope. The guy's going to not have too much trouble walking up it, maybe carrying the bike's a little bit harder, but it's not that hard to do. Okay, so when you have a graph, this is a really easy thing to do. If I were to just give you 2 points and ask you to do it, a little bit harder, and we're going to talk about how you do that tomorrow. All right, let's go on to the next page. Now, here's what I have asked. Can you write the equation of a line parallel to this line right here that passes through -8, -3? So -8, -3 is here. Now, I asked you to use the point slope form, and this is the point slope form. So we have our point right here. This is the point we're given, and we need the slope. If you'll notice, we need the slope. Remember how I said all equations that are linear equations have to have the y and the x? So those guys we're not going to fill anything in for. But the point, we're going to use these points. This is my x, this is my y, and we're going to call these our point that we're going to plug in. All right, so remembering that we have the slope of this line already, I'm going to go ahead and do another line that's parallel to this one. Let me get it drawn really quick so you can see the parallel lines. Okay, and they can be getting closer together. So let's make sure I've got that. I've got my rise of 1 and my run of 3, if you recall. So our slope was rise 1, run 3 on our original line. So a parallel line, you'll notice these lines aren't getting closer together. They're not intersecting. It's a rise of 1 and a run of 3. So we have our slope, which is 1/3. So if we were to plug that in for our m stands for slope if you didn't know, 1/3. And then we're going to plug in our points. So we have to do y minus our y sub 1, which is our point, and we're going to plug that in right there, y minus -3, and then our x comes down minus a -8, and we're going to do some math with that. Okay, so we're going to change. We got a double negative. That gives us y plus 3 equals. And over here, we're going to change to a positive 8. And we're going to have to multiply. That gives us 1/3 x. And we're going to have to multiply 1/3 times 8 really quick. So we're going to just turn it into a fraction. And that gives us plus 8/3. All right, now we're supposed to write it in slope-intercept form. And this is almost there. There's your mx, but we have a constant here and one over here. So we've got to move this guy over to this side so that we can finish. So now we just need to combine these. We have to use common denominators, multiply times 3 times 3. So we get y equals 1/3 x, and that's going to be 9/3. So 8 minus 9 is -1/3. And that takes care of doing that math. And if you'll look at this y-intercept, it's about 1/3 of the way down. There's 1/3, there's 2/3, there's 3/3. So you can see this is the exact answer. And you have to be careful when you're doing these kinds of problems. You can't just guess where it's going to cross the y-axis. You have to actually do the math. So I ask why you use point slope. This is important for you to know when to use it. So if you know why you use it, you'll know when. Why do we use point slope? Because I gave you a point that was not the y-intercept. This is slope-intercept. This is the y-intercept, but I didn't give you the y-intercept. If this was the y-intercept, this would be a 0. Okay, I gave you a point. And I told you to use the slope. So when you could find the slope because parallel lines have the same slope. So we have our old equation from the last problem, which was y equals 1/3 x plus 2, and we knew it was plus 2 exactly. So they have the same slope. Parallel slopes are the same, but they have different y-intercepts. Again, we used point slope because we had the slope and we had a point, and that helped us to write the equation of our line. Okay, so let's try another one. You write the equation of this line in slope-intercept form. Okay, well, if you look at this, I've got a much steeper slope, and by the way, it's falling. So let's find our slope. Here we have 2 points. Let's use our y-intercept and x-intercept. Our y-intercept is 0, 20. That's 0.1. Okay, so we're going to call this x1, y1. And this one over here is going to be 0.2 at 10, 0. Okay, so we're going to go back and use slope, how to find slope from 2 points. So if you'll recall, That's y sub 2 minus y sub 1. This is called our change in y over our change in x. How is our y changing and how is our x changing? You guys should recall this information. So we're going to plug our slope in. So our y sub 2 is 0. Our y sub 1 is 20. So our change in our y is negative 20. It went down 20 spaces, yeah? And then our change in x, which is our x sub 2 is 10, and our x sub 1 is 0. So that's 10. That gives us negative 20 over 10, which is negative 2. So we get negative 20, positive 10. But when we reduce that down, we get a slope that's negative 2. That really means for every 2 we go down, we go 1 over, we go 2 down, 1 over, 2 down, 1 over. That's how that slope works. So we have that slope figured out. Okay, so our slope is negative 2. So our equation is y is equal to negative 2x. That's our slope. And our y-intercept is right there. We don't have a problem with it, plus 20. So we have our slope. It's negative. Why? Because it's falling. It's down and right. Or if you go up and left, that's up 20 and left 10. Regardless of which direction you go, remember, if it falls from left to right, it's a negative slope. The y-intercept was 0, 20, and the rise over the run was negative 2 over 1, or just negative 2. So there's the equation of that line. Now let's see if you really get it. So remember the equation of this line. Let's write it down. It was y equals negative 2x plus 20. What I'm going to ask you to do is write the equation of the line that's perpendicular to this line that passes through the point negative 5 up 5. That's negative 5 up 5. And notice these are in units of 5, so we have to be careful with this. Again, point slope form is what we're going to have to do because we have a slope. Of course, we're doing perpendicular, so we got to think about what that means in regards to our slope. And we have a point. So we have a slope and we have a point. So perpendicular lines, watch this. I'm going to get this guy out. What I'm going to do is we're going to talk about the definition of perpendicular lines. So let me line this up and get it exactly 90 degrees here, or 180 degrees perfectly. And I'm going to make a mark at 90 because 90 degrees, lines that intersect at 90 degrees are perpendicular. And I've got my point right over here that I've marked. So what I'm going to do now is I'm going to take my straight edge of my protractor here. I'm going to move it over and I'm going to stretch it out a little bit and do a little run here. Speed it up. I'll get it. Be patient. Okay. And we're going to see perpendicular what happens to our line that passes through those points. Okay. That's perpendicular. Now I'm going to prove that it's perpendicular. Let's make sure that it is. It should be at a 90-degree angle. Let me get it totally perfect. Oops, I didn't do a very good job. So let me fix that up real quick. Be patient. Okay, 90 degrees is up here. I don't know how that worked out before. But let me move this line a little bit so that it is 90 degrees so you can see how you can do the shortcut, because I certainly don't expect you to figure out, use a compass all of the time to determine whether, oops, darn it, whether you are having perfect perpendicular lines or not. So I'm not quite there yet. So I'm just going to squeeze this in and I'm going to use I'm just going to do this. And we're going to make it exactly perfect. There we go. So you can see now that it's passing through negative 5, 5, and it's crossing 90 degrees. And it's 90 degrees to this line right here. So we've got a 90-degree angle, okay? All right. So let's talk about the slope of this line here, okay? We have to use points along this line that intersect. And so let's see. From there to there, we have 2 points on the line that intersect at intersections. So we've got a rise of 10 and a run of 20. So the slope of this perpendicular line, perpendicular, this is the symbol for perpendicular, is 10 over 20. And it's a rise of 10 and it's a run of 20. So that reduces down to 1/2. Okay? So the slope of the perpendicular line is 1/2. Now, how do you determine that? When you're looking for perpendicular slopes, and that's how you determine it, they're 90-degree opposites. What you do is you take the slope of one line and you flip over its reciprocal and you change its sign. If it's a negative, you have to use its opposite reciprocal. So negative and positive, that's the opposite part. The reciprocal is the flip part. And you'll know it's right if you multiply them and you end up with the product -1. You might want to put that in your notes. Perpendicular slopes will multiply to give you -1. Okay, that's one thing that you've got to know. Okay, so big thing to learn. Perpendicular slopes have a opposite reciprocal slope. So let's take a look at our information. Our slope of our red line, our slope is 10 over 20 or 1 over 2. 10 over 20 reduces down to 1 over 2. So it has a slope of 1/2 and it's passing through the point -5, 5. So we're going to write the equation of our line now. So we're going to use point slope again. Y minus our y sub 1 equals slope times x minus our x sub 1. And we're going to do that math. Okay, so we got y minus 5. We're going to have to change our double negative and distribute. So that gives us, let me erase this stuff out of the way a little bit. Okay, so that gives us y minus 5 equals 1/2 x. And then you're going to have to do 1/2 times 5. And that's 5/2 if you want to check 1/2 times 5. It's 5 over 2. Okay, so you got 5/2. And then what you've got to do is it's almost ready to, the equation's almost done. You've just got to put it in slope intercept by moving this 5 over to this side. All right, so you get, we did it this way, didn't we? 5 over 1. So we're going to have common denominators. It's not that hard. So we get y equals, the equation of this line, y equals 1/2 x, and that's 10 over 2. So plus 15 halves, which works out to 7.5. And if you look at it, that's pretty much halfway between 5 and 10. So your y-intercept is 7.5. And it's okay to write your equations like this in algebra. And so that's how you do perpendicular. Okay? So that's what I got for you. Things to be ready for tomorrow. Okay? You have to be able to find the slope of a line that passes through points. So remember, this is your x1, y1, and your x2, y2. And you have to use your slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In your notes, I better see the answer to this question. And then I want to know the equation of the line, write the equation of the line from number 1 using the slope that you find and use this point. Okay? So use point 1, x sub 1, y sub 1. So use point slope, find your slope from number 1, put it right here, and then do your y minus your y sub 1, you're going to get that right here. And your slope times x minus x sub 1 right here. And then distribute and move it over and write your equation because it has to be in slope-intercept form. Be able to tell me how you can prove the difference between parallel lines and perpendicular lines. How are you going to know the difference? It's all about the slopes. And make sure you have all these formulas written down. This is point 1 and point 2. So if I give you 2 points, here's how you find the slope of 2 points, just the slope. You do your change in y over your change in x, okay? That's what this little triangle means, change in. This is point slope. We use point slope form when we have a slope and we have a point that's not the y-intercept. We use slope-intercept when we have the slope and we have the y-intercept. We know where it's crossing the y-axis. This makes life easy. Okay, so make sure you know you can answer all of these questions so you can do tomorrow's assignment. All right, guys, thanks. Have a good day. Bye.